sulfuric acid H2SO4. First one is here physical properties. Physical properties of sulfuric acid. Now here sulfuric acid is generally colorless, oily, less volatile, highly corrosive liquid. Less volatile and highly corrosive nature liquid. This is. Then now its specific gravity. Specific gravity is 1.84 at 298 kelvins. Okay, next. It boils at or it freezes at 283 kelvins and boils at 611 kelvins. Okay, so these are the some important physical properties of sulfuric acid. And here chemical properties. Here in chemical properties of sulfuric acid. It is highly soluble in water, H2O. So while preparing dilute sulfuric acid from concentrated sulfuric acid, we must take a care, because here while preparing to convert concentrated sulfuric acid to dilute sulfuric acid H2SO4 means its concentration direct 96 to 98% concentrated sulfuric acid is converted into dilute sulfuric acid. We must take a care about dilution of sulfuric acid, because while dissolving sulfuric acid or while diluting sulfuric acid, it liberates a large amount of heat. It is an exothermic process. Extensively more amount of heat is liberated. Suddenly if we can add concentrated H2SO4 to the water, spread out easily, because it is an extensively amount of heat is liberated and exothermic reaction easily spread out. That's why to the water, large quantity of water, this is the one beaker to this large quantity of water, H2O. So to this large quantity of water, just add drop by drop with constant stirring. Now just add concentrated H2SO4 drop by drop only. Just add to the large quantity of water. Just by using test tube, just add 1 drop and stir it. Just 1 drop, stir it. That's why while preparing dilute sulfuric acid, we must take a care, always add concentrated H2SO for small quantity, drop by drop in a large amount of water. This is the correct method to get the dilute. But don't dissolve here to the concentrated H2SO4. Don't add water. This is the wrong method. Don't add water. Wrong explanation. easy to spread out. Easy to spread out means you are extensively more amount of heat is liberated. That's why don't add water to the concentrated H2SO4. Just add concentrated H2SO4 to a large quantity of water, drop by drop, then only we'll get the dilute sulfuric acid from concentrated sulfuric acid. So extensively large amount of it is liberated while dissolving sulfuric acid in water. That's what is an exothermic process, really soluble. By using all these, you are in chemical properties due to low volatility, your high acidic nature. Third one is large amount of heat is liberated. Large amount of heat is liberated, and strong affinity towards water, towards H2O, and acts as an oxidizing agent. Strong oxidizing agent acts as an strong oxidizing agent. Strong oxidizing agent. It shows some important peculiar properties, and it is widely used in different uses in different ways in different processes or different methods industrially or in laboratory. So by using all these, our sulfuric acid is a strong acidic in nature. Strong acid, it is strong acidic character means strongest acid and acidic character. It ionizes sulfuric acid H2SO4 ionizes against H plus HSO4 minus 1. This is its dissociation constant Ka1 is always greater than or approximately equal to 10. This is now this is bisulfate again ionizes against H plus SO4 minus. Your dissociation constant in second step, that is 1.2 into 10 power minus 2. Now here the Ka1 is greater than always Ka2. This is now here the dissociation constant is always first one is greater, completely ionizes than here Ka2. So by using this, here the sulfuric acid, it is a diabasic acid. Its basicity is 2, diabasic acid. Now by using diabasic acid, basicity is 2. Its structure we know already. Sulfuric acid structure. Now here in structure of H2SO4, one sulfur that is connected with 6 bonds like this. These are 6 bonds, like among these 4 sigma bonds are there and 2 pi bonds are present. 2 pi bonds are present. That's why this sulfur undergoes sp3 hybridization, tetrahedral geometry. In these 2 OH groups are there. This Hydrogen atom is indirectly bonded with sulfur. This is through oxygen it is bonded. These two are easy to replace. That's why these are replaceable hydrogen atoms, H atoms. That's why its basicity is equals to 2. It is a diabasic acid. So on the basis of all these, based on their due to low volatility, high acidic nature or acidic strength, large amount of heat is liberated, strong affinity towards water, and acts as a strong oxidizing agent. By using all these, due to the low volatility, it reacts with some respective metallic salts. It liberates high volatility acids. So by using this first point, here sodium chloride metallic salt react with like sulfuric acid H2SO4. Sodium chloride react with sulfuric acid, a gas here Na2SO4 plus 2HCl hydrochloric acid is formed. This is highly volatile. This is low volatile. Low volatile liquid react with corresponding metallic salts. Against here the highly volatile liquid, highly volatile solids, acids are formed. Sulfuric acid react with these metallic salts. It gives highly volatile acids, and also it forms a normal acids. Normal acids are formed, and also it reacts with less amount of these NaCl react with sulfuric acid. It forms like NaHSO4 plus HCl is formed, like also volatile acid. This is the hydrogen sulfates. Hydrogen sulfates means sodium hydrogen sulfate, or also we can use sodium bisulfate is formed. Finally, by using low volatility of sulfuric acid, it reacts with the corresponding salt solution. It gives the corresponding respective highly volatile acids are formed, as well as normal acids, that is normal sulfates, as well as hydrogen sulfates are formed. Not only this, it reacts with magnesium chloride, calcium chloride, or whatever. It gives corresponding magnesium sulfates, as well as magnesium bisulfate, calcium sulfate, CaSO4, calcium hydrogen sulfate, like sulfuric acid forms corresponding normal sulfates as well as hydrogen sulfates. That is due to the low volatility of sulfuric acids. It creates normal sulfates as well as hydrogen sulfates, and also highly volatile acids also produces. This is already explained. And large amount of heat is liberated. Strong affinity towards water explained. And it acts as a dehydrating agent. Sulfuric acid acts as a dehydrating. Industrially, many gases, moisturized gases, are dried by using a concentrated sulfuric acid. Already, in the manufacture of sulfuric acid by contact process, impure moisturized sulfur dioxide gas is purified, dried by using concentrated 98% sulfuric acid. Not only this, any respective moisturized gases are dried by using concentrated H2SO4. That's why the concentrated H2SO4 acts as a dehydrating agent. Concentrated sulfuric acid acts as a dehydrating agent. It is used to dry some different moisturized gases. So the concentrated H2SO4 acts as dehydrating agent. Dehydrating agent. There are many moist gases are dried by using concentrated H2SO4 sulfuric acid. Like moisturized sulfur dioxide, trioxide gases are purified, dried by using this. Based on this dehydrating agent, one of the most important example is charring or burning. Burning of the sucrose or any organic compounds on heating with concentrated H2SO4 like C12H22O11 plus H2SO4. It is concentrated hot sulfuric acid. This carbohydrate, that is sucrose, it is a carbohydrate. This carbohydrate complete burning, that is charring, takes place. It dehydrates the water present in it, gives 12 moles of carbon plus concentrated sulfuric acid is converted into a dilute sulfuric acid. Here without water, here 11 moles of water is formed. It is dilute sulfuric acid. That is charring of sucrose. Not only this, depending upon the condition, some organic compounds like formic acid, COOH, it is a formic acid, methanoic acid. Common name is formic acid, methanoic acid, IUPAC name. On heating with concentrated H2SO4, it liberates carbon monoxide gas and sulfuric acid. Dilute 1 mole of water is reacts, dilute sulfuric acid. Same thing here, oxalic acid, that is COOH, bond here the COOH, that is oxalic acid, that oxalic acid formula C2H2O4. On heating with H2SO4 concentrated sulfuric acid, gives carbon monoxide and carbon dioxide plus here the sulfuric acid dilute H2SO4 is formed. These three reactions are very important, already given in previous object as well as in PU or in theory. So on charring of this glucose or any carbohydrate, it gives corresponding charcoal, that is carbon. This is important, carbon. Now here the formic acid or the methanoic acid containing only one carbon, that's why it gives the carbon monoxide gas. But here two carbon atoms are there, one is carbon monoxide and the one is carbon dioxide. Remaining OH and H, it forms water molecule, dilute sulfuric acid. It liberates both the gases, carbon monoxide and dioxide gases. Regularly in objective in CET level, they will ask which gas is liberated when formic acid is heated with the concentrated sulfuric acid. They will create the options like carbon, carbon monoxide, carbon dioxide, both carbon monoxide and carbon dioxide gases. A very important chemical reaction. So on the basis of this charring or the burning are reacted with the concentrated H2SO4. In organic chemistry, alcohols, phenols and ethers already completed one important chemical reaction, that is here alcohols reacted with sulfuric acid, concentrated sulfuric acid. This is CH3, CH2 bond of H is heated with concentrated sulfuric acid, H2SO4, concentrated sulfuric acid. Depending upon the temperature, here we can heat it 140 degrees Celsius that is 413 kelvins, will get one answer. If it is 170 degrees Celsius, that is 443 kelvins, will get one more answer. Very, very important. At 140 or 413 kelvins, with the help of this water eliminate, here we can take 2 moles of ethyl alcohol against the corresponding ethers like CH3, CH2 bond O, CH2 bond CH3 plus water is liberated. So the diluted sulfuric acid water means your ethers are formed here. Very, very important. Preparation of ethers by using primary alcohols, that is dehydration of primary alcohols at 140 degrees Celsius and use corresponding ethers. Whereas in case of second case at 170, only take 1 mole of this ethyl alcohol on heating gives alkene, CH2 double bond CH2 plus water is formed. This is a very, very important mechanism, dehydration of primary alcohols to alkenes. This is alkene, that is ethene. Clear? These are the some important dehydrating or the charring or the burning of some organic and inorganic compounds. Similarly, this concentrated sulfuric acid also react with metals and non-metals. It gives a corresponding sulfur dioxide gas. It acts as a mild oxidizing agent. It is mild oxidizing agent lie between your P2O5 as well as HNO3, concentrated HNO3. It acts as a mild oxidizing agent. That oxidizing nature is lie between P2O5 as well as HNO3, nitric acid. Hence, it reacts with some metals and non-metals. It gives corresponding sulfur dioxide gas. So here, concentrated H2SO4 reacts with metals as well as non-metals based on their oxidizing capacities. So here metals means here the copper is reacted with concentrated hot. Here the reacted with concentrated and hot sulfuric acid on heating. Gives copper sulfate plus water diluted plus sulfur dioxide gas is liberated. It is a metal. React with this 2 moles of hot and concentrated sulfuric acid. It gives copper sulfate, water and that. Here take 2 moles. It is clear. Here 1 mole sulfur and there 1 mole sulfur is balanced. Now it reacts with generally here it reacts with carbon. It gives concentrated sulfuric acid, hot and concentrated. It gives carbon dioxide. Here the water and sulfur dioxide gas is liberated. Here carbon dioxide like sulfur dioxide, take here moles here 2 moles of this, here 2 moles, take here the 2 moles of this. Also here sulfur reacts with concentrated H2SO4 sulfuric acid. Gives water plus 3SO2 sulfur dioxide gas is liberated. Take here the 2 moles of here the hot and concentrated sulfuric acid. These are the some important chemical properties about sulfuric acid, concentrated sulfuric acid. Then most important thing is last uses of sulfuric acid. Already in manufacture of sulfuric acid, starting itself explained to you about concentrated sulfuric acid. That is It is sulfuric acid is called a king of chemicals. So why it is called a king of chemicals? Explained. It is used widely in different various processes industrially as well as in the laboratory. That's why it is called a king of chemical. Some important uses of concentrated sulfuric acid are here. Uses of H2SO for sulfuric acid. So mainly in refining of petroleum products, very important, like soap industries or in the manufacture of fertilizers. Fertilizers means like ammonium sulfate, superphosphate, or superphosphate, like fertilizers are in soap industry or like refining of petroleum products. So many important applications are there. Uses. Yeah, it is used in a lead storage batteries. Lead storage batteries, sulfuric acid is used. In second year, in electrochemistry, will explain this lead storage battery like. So variety applications like in organic chemistry in the laboratory or in organic chemistry while doing some chemical reaction as laboratory reagent or as a organic reagent, as a dehydrating agent, as dehydrating agent, or as an oxidizing agent, we can use this H2SO4. Like here, one of the most important that is pickling processes, like anomaling process, your galvanization process, like anomaling, pickling or galvanization process. Here anomaling or the pickling or galvanization means before coating with the help of oils or the paints on the surface of the iron or any metallic rods, such as rusted metallic rods are cleaned with the help of first sandpaper, then it is cleaned with the help of sulfuric acid, then finally it is coated with the help of some oils or the paints. That's why industrially, yeah, sulfuric acid we can use in different ways, like in laboratory or in organic chemical reactions. Different ways we can use in different applications. That's why it is called a king of chemicals. Some more important use given in our textbook, but you read from textbook. Almost all points covered in 16th group elements. About all 16th group elements like oxygen, sulfur, selenium, tellurium and polonium, each and every one element introduction, general points and some important compounds of 16th group elements like oxygen and sulfur compounds explained. Very, very important. In P block elements, two groups are successfully completed. There are 15th group and 16th group elements. Now, today I will start about 17th group elements, new group. Then it will take 4 to 5 classes. Then last 18th group is there. In 18th group element also we'll get 1 or 2 questions in object. Then I'll start 17th group elements. So here, this is 16th group is completed. This is 17th group elements. In P block elements only, among 4 groups, third one is, this is 17th group elements. Now in 15 and 16, very clear information given about each and every one element. Similarly, in 17th group also, there are some important points about each and every one element. First, I will introduce as 16 and 15th group elements. Then I'll explain some important compounds of 17th group elements. Before that, all the students listen carefully. After this 17th and 18th group, I'll conduct one simple test, online test. I'll send one question paper. I'll give the time. Be ready for that exam. Very, very important unit, P block elements. In second year, highest weightage inorganic part, P block elements, 10 marks. And it is look like a one word answer concept. This is, there is no direct big question like a 3 marks question. Better you concentrate on only 1 mark and 2 marks. Okay, so don't neglect, read thoroughly. So anyhow, here in this 17th group elements, first about introduction about this 17th group elements. Introduction. In this introduction, first one is here fluorine, chlorine, bromine, iodine and astatine AT are collectively called 17th group elements. 17th group, that is also called a fluorine family. Fluorine family. This fluorine family 17th group elements are collectively called, these are also called a halogens. Halogens. Why these are called halogens means, in Greek language, halo is nothing but salt. Your gens means producers. Gens means producer. These are the salt producers. Like salt is nothing but sodium fluoride is a salt. Sodium chloride is a salt. Sodium bromide is a salt. And here the sodium iodide is a salt. That's why all these group elements like fluorine, chlorine, bromine, iodine and astatine are collectively called halogens. Your astatine is a radioactive element. It exists as in atomic state, not in molecular state. These are represented as X. Your X are fluorine, chlorine, bromine, iodine and astatine. It is a radioactive element. A radioactive element it is. So here due to the presence of 7 valency electrons in its outermost orbit, like these are the 7 valency electrons in its outermost orbit. Like here the fluorine contain 7 valency electrons, like this fluorine is ready to accept 1 electron from other atom of an element. It forms a diatomic molecule. Between halogens and halogens, there exist even covalent bonds. Mutual contribution and mutual sharing takes place. It forms fluorine bond of fluorine. On each fluorine, 3 lone pairs are there, like 3 lone pairs. Now it is small in size. Around fluorine, your electron cloud is more. Here are 6 electrons and here also 6 electrons are there. Electron cloud. This electron cloud is very, very important to get some bond dissociation energies. Finally, this halogen exists as a diatomic like X2, like it is fluorine, chlorine, bromine, and iodine molecules. These are molecular state that is due to the presence of this number of 7 valence electron to get the octet electronic configuration. They are ready to accept and it forms in a diatomic nature X2 molecule. Like fluorine, chlorine, bromine, and iodine, all these halogen molecules or atoms are highly reactive non-metals. Highly reactive non-metals, very, very important. They are ready to accept the pair of, ready to accept the electrons to get the octet electronic configuration. They are nearer to the noble gases to get the octet electronic configuration. To attain the stable noble gas electronic configuration, they are highly reactive. They are ready to form one covalent bond to get the molecular state like F2Cl2, Br2I2. And these molecules are highly reactive in nature, non-metallic in nature. But their non-metallic nature, top to bottom, slowly decreases. I'll explain that. After this simple introduction about 17th group elements, occurrence of these halogen atoms. Occurrence of halogens. Occurrence of halogens, availability. Generally, your fluorine and chlorine exist as fluorides and chlorides present in sea water under the name of certain salts, like here about fluorine, mainly it is a fluorospar, that is calcium fluoride. It is your cryolite, that cryolite is Na3Al6. It is a double salt it is, because it contains NaF sodium fluoride 3 moles plus AlF6 aluminum fluoride. It is a double salt because it contains 2 simple salts. Already in 15th group elements explained to you, that is apatite family, under the name of apatite family, that is fluoroapatite family. That fluoroapatite formula is Ca3PO4 taken twice, and CaF2 is the fluoroapatite, 3 moles of this molecule. And this fluorine is also present trace amount, small amount of trace amount of fluorine also present in the seawater plants, sea plants and animals, and animal bone teeth contain some trace amount of this fluorine. Here chlorine also Cl2, some important salts present in seawater, like one is sodium chloride NaCl. Second one is your carnallite. This carnallite is KCl MgCl2 6H2O. It is also a double salt. It contains KCl1 and MgCl2, one simple salt. So the seawater contain 10% NaCl solution is called a Brin solution, like some important like occurrence. Chlorine exists in combined state like salts and some minerals like, and chloroapatite family is there. This chloroapatite family is same Ca3PO4 taken twice and CaCl2 like. This is the occurrence of fluorine and chlorine. Now here the bromine and iodine also present a trace amount in seaweeds containing some trace amount of bromine and iodine. These are the some important points about occurrence of fluorine, chlorine, bromine and iodine. Already astatine explained, astatine is a radioactive element. Remaining except astatine, remaining all elements exist as a diatomic molecule, that is X2 like fluorine, chlorine, bromine and iodine. Clear? After these electronic configurations of these 17th group elements. Okay? Listen carefully. So are the electronic configuration of 17th group elements. Here the general electronic configuration of 17th group elements is here rare gas NS2 NP5 is the electronic configuration. Here N start with 2, 3, 4, 5 and so on. This is. Yeah, number of valence electrons are here 7 are there. In S subshell it contain 2 electrons are paired, and in P subshell it contain 5. Among this 5, 2 are the paired, one is unpaired is there. Due to the presence of this unpaired electron, ready to take mutual contribution, mutual sharing to get the one covalent bond between fluorine-fluorine or chlorine-chlorine or any halogen and halogen atoms. So on the basis, your element is first one is fluorine. Fluorine, its symbol is F. Atomic number is 9. Atomic number is 9. Based on this, electronic configuration is, for this electronic configuration, EC is 1s2, 2s2, 2p5. Here 2d orbitals are not present. Same explanation about fluorine, just like oxygen and nitrogen. In 15th group elements, nitrogen, and in 16th group elements, oxygen. In 17th group elements, fluorine. Same anomalous properties of nitrogen, anomalous properties of oxygen, anomalous properties of fluorine. Same concept. Absence of d orbital, small in size, atomic size, and high electronegativity of this first member of this group shows some anomalous properties, specular properties. Now in its outermost orbit, here 7 valence electrons are there like this. Among these 7, 3 are the paired, 1 is unpaired. Here absence of d orbitals, absence of d orbitals, and small in size, small in atomic size, and high electronegativity shows some anomalous properties. I'll explain after that. Whereas in case of chlorine, this is second element, chlorine. Now chlorine symbol is Cl. You are added to this 8, 17. Electronic configuration is neon 10. Now here the 3s2 and 3p5. 3d is there, availability is there, d orbital. Here bromine, for bromine, your symbol is Br, add again here 18, 35, that is argon 18, 3d10, 4s2, 4p5 is the electronic configuration of this bromine. Your iodine again add here 18. If you can add 18, 52, we'll get it. Your 18, 53. Now this is the krypton 18. Your 36. 4d10, 5s2, 5p5 is the electronic configuration of this iodine. Last, finally, astatine. It is a radioactive element, that is 80. To this add 32, 85, will get it. Now this is xenon, 4f14, like 5d10. 6s2, 6p5 is the electronic configuration of astatine. So these are the 17th group elements: fluorine, chlorine, bromine, iodine, and astatine. Symbols and atomic numbers like 8, 18, 18, 32 by adding like this, we will get atomic numbers and electronic configuration. Yeah, chlorine onwards in its outermost orbit, vacant d orbitals are there. Electrons are excite and possible excitations, so 3 excitations takes place. Because here 1, 2, 3 are there paired, these 3 are excite. Total 3 excitations are possible for chlorine, bromine, iodine, and astatine. Very, very important electronic configuration. How it excites, how it shows variable oxidation state. After some important physical properties, I will cover this excitation of electrons from its outermost orbit. Okay, we'll discuss some important physical properties. Physical properties of 17th group elements. One is radius, covalent radius, ionic radius, covalent ionic radius, that is in ppm, sorry, pm this is, also pm this is. Third one is ionization energy or ionization potential. Fourth one is electron affinity. Fifth one is electronegativity. We'll discuss these some important points of 17th group elements. So once we can observe the electronic configuration of 17th group elements, top to bottom atomic number increase, a newly added electron enters into a new main energy level. So whenever the electron enters into a new main energy level, top to bottom size increases, effective nuclear charge decreases, then size increases. Here we know general electronic configuration ns2 and np5. Here n is start with 2s2 and 2p5 for fluorine. Here 2 energy levels are there like. For chlorine 3s2, 3p. For chlorine here 3s2, 3p5 is there like 3 energy levels are there like. Like bromine 4 energy levels are there like. Top to bottom what happens? Number of energy levels increases. 1, 2, 3, 4 like 5. Atomic number increase. Energy levels increase. Here the distance between the nucleus and outermost orbit increases. It's a covalent radius in picometers or angstrom units, top to bottom, what happens? Size increases. Size increases. That is in terms of covalent radius. That is fluorine is greater than, fluorine is less than, chlorine is less than, bromine is less than iodine. So the top to bottom covalent radius increases. Now ionic radius also F minus is less than, Cl minus is less than, Br minus is less than I minus. So both your covalent radius and ionic radius increase because your top to bottom atomic number increase. A newly added electron enters into a new main energy level, size increases, distance between the center of the nucleus and outermost orbit distance increases, its covalent and ionic radius increases. Now ionization energy is inversely proportional to the size. Size increases, ionization energy decreases. So on the basis of this, your fluorine is greater than, chlorine is greater than, your bromine is greater than iodine. So here the fluorine has highest ionization energy among all these elements. Now electron affinity, we know already amount of energy is released when one electron is added, isolated neutral gaseous atom to get the X minus are the mono-negative ion. So you're bonding your electron to the fluorine and bonding one electron to the chlorine, one electron to the bromine, one electron to the iodine, generally amount of energy. It forms like F minus, Cl minus, Br minus and I minus. Amount of heat is liberated, that is exothermic reaction. Electron affinity top to bottom generally increases, but whereas in case of this means generally you are small in size, are ready to accept the electrons, more amount of it is liberated. But in this case particularly fluorine, chlorine, bromine and iodine, in each and every one group every second element has highest electron affinity among all known elements. Highest electron affinity element is Cl. Not only in this group, among all elements in the long form of the periodic table, highest electron affinity is this. Reason already starting explained to you. Here in this fluorine, to accept the one electron to the fluorine, to accept one electron due to its small size, your electrons are more number of electrons are present. It is electron and electron sign is same. Between these two electrons, inter-electronic repulsions takes place. Due to the inter-electronic repulsive forces, this electron cannot enter easily into this fluorine atom. That's why liberated heat is less. Even though small in size, even though more attractive nature, in atomic state cannot accept easily electrons because of small size and presence of more number of electrons. So due to the presence of this inter-electronic repulsions, while adding one electron to the neutral isolated gaseous atom, less amount of energy is released. That's why electron affinity, electron gain in enthalpy is less than compared to the chlorine. That's why chlorine has the highest electron gain in enthalpy. That is, order is here. Cl is greater than compared to the fluorine, than compared to the bromine, than compared to the iodine. Then finally, electronegativity of 17th group elements. We know among all known elements, fluorine has the highest electronegativity element, that is 4 its value, electronegativity value. That is electronegativity order is fluorine is greater than, chlorine is greater than, bromine is greater than iodine. These are the some important points about 17th group elements, some physical properties tomorrow we'll discuss. That is density, melting and boiling points, and bond dissociation enthalpies between fluorine and fluorine, chlorine and chlorine. Tomorrow we'll discuss about all these. Okay? Sandeep sir?